And so now, again, a slight more shift in topic here. Again, still in our data theme. So, right, so we've collected lots of data in various places. We've shared it or not as appropriate with folks. But now we want to put all this data into a form that may be able to say more than words can say, right? Thinking about how do we visualize this data that are appropriate for the data source, for the folks who are going to be the recipients of this data, that accurately reflect all the nuances that data can provide. And so we now have Lilja from Cheniere Energy to give us a presentation about data visualization and specifically from a private sector perspective. So let's welcome Nick.
The hope of this presentation would be that maybe you guys can have the wheels turning in your head while I'm talking about a lot of the things that we do. At where I work, we have 2 meteorologists on staff. For most of the energy industry, you'll have at most 1 meteorologist on staff at a particular place. Other than that, generally what they do is they'll just take model data and grip and rip. They take the John Daly approach to stuff, for those of you that are golf fans from the 80s and 90s. So what is it that you do here exactly, Nick? Well, I talk to the No, I don't. We do weather forecasting for the entire globe every day. My forecasts are generally for Europe and Asia, as well as a spot forecast for a couple of places around the country. I do a lot of renewable forecasting as well. We'll do regional stuff, so that'll be mainly precip and temperature. We've got, again, the renewable stuff for US, Europe, and China, and then we do local forecasting as well. And that local forecasting is very, 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 very specific. And it's got to be right. And the toughest part about our job is we've got to be correct. We have to communicate it well, and we have to do it very quickly, especially in high-impact weather, but also just kind of generally. My day starts, I get up at 4 a.m. every morning. My day starts at 5:30, because I have to have everything done by the time that our energy traders and everybody else gets into work, because they need this information to make their decisions. So anything that I can do to speed up the process of getting the data into my hands and then turning that around in a way that I can communicate that to people is invaluable. And what has helped with that is ChatGPT, of all things, because it really allows us to do a lot of just mundane, stupid stuff very quickly. For instance, there will be times where I'll wake up in the morning and I'll have an email saying, hey, we've got these 50 cities in Europe that we need to know what the wind speed is going to be at 120 meters between 3 o'clock this afternoon and 7 o'clock tonight. That's all I get. And we need this, and it's Europe people that are talking to me, and they're like, well, I need this now. And I don't have time to look at the lawn points for all these cities. I don't have time to figure out what country they're in. I don't have time to figure out what the nearest airport code is, and that's where ChatGPT comes in handy. Yeah, there's a lot of QCing you need to do with some ChatGPT stuff, but that's a whole lot faster than me sitting down and going, okay, where is this city? It's in this country. What is the lawn point? What is the nearest airport code? And doing that for 50 or 100 cities. Our workflow has changed a lot in the last probably 3 to 6 months since we started utilizing ChatGPT and now Python. And as a for fun, what isn't on this is, and I forgot to mention here, is at the bottom, I actually asked ChatGPT to make this presentation cooler. And so it decided, and I decided with it, that we are going to title all the slides using Gen Z slang. And so hopefully, professors, you can take this back and understand what your kids are talking about. This was also fully approved by the Gen Z kid that sits behind me at work. He's a recent grad, and I don't know what half of this stuff means. So what I use ChatGPT for mainly, outside of the mundane stuff, is solving the problems that I come across with in Python. Now, most of you people that I've had a chance to meet in here don't need this. You guys are already miles ahead of where I am, which is why I love being here with you guys, because I can just osmosis and steal all of your awesomeness. But for me, and I don't usually screenshot my errors, so this one's actually a really easy one to solve. But if I am writing up code and I get to a part where I get an error or I don't understand what the problem is, I just go to ChatGPT and I'm like, where did I screw up? And ChatGPT is like, you're an idiot, this is the problem. And I say, thanks, Chatty, and I move on with life. It's a whole lot easier. So we need a glow up, which it means we need to do better. That's at least what I was told. So one part of the private sector that we have a big problem with is we lack data. In academia and even in other sections of the private sector, I suppose, but you guys get these like mesonettes. So I got a buddy that's taking over the Wisconsin mesonet. They're building a whole mesonet for all of Wisconsin. That's great. We get one sensor. And then when we went to people in our work and we were like, hey, they're like, hey, your weather forecast needs to get better. And we were like, hey, we need a mesonet. And they were like, ooh, okay. And I don't have this in the thing because, but I'm probably not supposed to tell you guys this, but I'm going to. This isn't recorded, right? Oops. So they came back to us and they said, hey, here are these 12 sites that we've got in the area. And I was like, okay, how close are these 12 sites? And they put it out on a map. And one of them was 10 miles down the road that way. We had 3 of them, all within about a quarter mile of each other. There was one to the north, 25 miles. There was one to the south at 5 miles. And then there were a couple more that were personal weather stations that were just kind of in and around. And they said, yeah, right? Really helpful. And no, you guys need a weather forecast to be here and this direction, and all of your stuff is all over there. And so we get stuck with our one thing because they don't want to invest in all of the money that goes into doing a mesonet. So it gets really difficult to do our job. Poor Kim knows this because I go to her frequently with all of my problems. That we need to have data and a forecast, and we need to have it very quickly, and we need to communicate it very well, and the data that we get to support the weather forecast that we put together, in particular for local stuff, sucks. So if anybody's sitting out here right now and you're going like, oh man, I really need to, I got a project that I've really thought about doing. It has to do with fog forecasting, and it has to do with ship channels. I'm listening. The people that I work for are very interested also. Because we talk to decision makers, and we need to give them information in words they can understand. And our public is a varying degree of education. I'll talk to the CEO of our company on a semi-regular basis, and I will also talk to a pilot of an LNG boat. Those people have 2 very different backgrounds. I don't know if you've ever talked to a ship captain before, but they didn't go to an Ivy League school. Generally, they're just like a guy that knows how to drive a boat and got really good at it over time and drives a bigger and bigger boat, and probably didn't go to college, probably didn't go to community college. I talk to people sometimes that didn't even finish high school. So telling them about perturbations in the atmosphere has very little meaning, as you can imagine. So visualizations become a big part of what we do. And we write a lot. You can imagine doing a handful of forecasts every day, that any extra picture that I can have is going to help me, because too much text is boring. In fact, part of this slide is a joke. There's no pictures on here, it's just text. And all of you, I would assume right now, are very bored looking at the screen. Plus, we're taught as kids, as we grow up, that everything weather comes with a visual. I'm sure we all grew up watching TV, watched the news once or twice. No one gets on TV anymore and just reads a bulletin from the National Weather Service and says, okay, back to you. It's pictures, it's graphics, everything is visual when it comes to weather, and so we do the same thing. A picture is worth 1,000 words, they say. We'll talk about that in a second. But they can grab people's attention very quickly. If you live in Florida and you see a spaghetti plot with all of the spaghettis pointed toward you, as a meteorologist or somebody in the atmospheric science field, you kind of know what that means. If you're a regular schmo, Susan would say you don't really know what to do with this information, but you know it's bad. Is that probably pretty accurate? Yeah. And we also use graphs because those can be pretty intuitive. Most people know how to read a graph if it's a basic graph. People, our public at least, also needs the physical numbers. They need to be able to grab the physical, actual number out of the data that we provide. And again, no one wants to read. And I know this, so I send out emails. I send anywhere between 10 and 20 emails a day. I tend to put at least one Easter egg per day in an email. I hear back from people maybe once or twice a month. So no one reads my emails, which is great, because that's why I get paid. Viz is totally boss. Again, I'm told that's really cool. So for trends for singular data, we tend to use graphs. And that can usually tell a pretty decent story in one quick look. That's the guy up here in the upper right. You can kind of tell, even by looking at that. You may not know necessarily what those graphs mean specifically, but you can tell, one's going down, the other one's going up, and you can kind of grab it and go. Usually, the good news about that is you can know what's happening either before right now, after right now, and right now. For multiple linear and incremental data sets, we tend to use maps. That would be like, what's the precip looking like, for instance, in the afternoon over a large area. That can't tell you what's going to happen before that. It can't tell you what's going to happen after that. But it can say, okay, at 3 o'clock today, you're going to have rain. And then for big, large data sets with simultaneous and multiple things, we tend to use maps and charts at the same time. And after talking with Susan, I'm actually learned that that's probably not the best way to go about things and overload my wonderful people with stimuli. So I want to walk you guys through just an example forecast that we give. And this is from, I think, like March or April. And this is a forecast for over in Europe. And yes, I do a 60-day forecast. This is halfway through my 60-day forecast. You can see the variability that we have here within your HDDs and CDDs. Is everyone generally familiar with HDDs and CDDs? I'm getting some kind of of these things. Okay, so you take 65 degrees. If you're warmer than that, it's a CDD. If you're cooler than that, it's an HDD. The idea being that your heating demand, people are going to turn their heat on if the average temperature for a given day is below 65 degrees. People are going to turn their air conditioning on if the average temperature for a day is above 65 degrees. That's not really how it works, but it's the best we can do. If you're sitting here right now as a data scientist going, I have a better idea, I am very much listening. And so here's the forecast, and basically the narrative that we write, we just use the graphs here to either support it or explain the graphs with the narrative. In this case, I'm talking about going warmer than guidance for many reasons, which I'm about to get into, because I don't like what guidance is doing. And how many of you guys work with teleconnections ever? Yeah, okay. Seasonal forecast people. And so in this particular case, as we moved into April, so again, this is from March, the EA was leaning way negative. And in Europe, when the EA goes negative, I'll give you guys some inside baseball. That means it's going to be cool. Don't tell anybody that I just told you that, because that's definitely a trade secret. It's not. But it is something that not a lot of people pay very close attention to. And so we go a little negative, but I'm saying I tend to think that we're going to have to lean warmer than the forecast, because even though we've got a bunch of negative EA here, there's probably more risk that we're warmer than what's shown here. And that risk becomes very important for the people that I work with. Unlike the public, the general public, my public can understand risk and how to manage kind of the difference between a 20% and an 80% chance for blank. We annotate a lot on our images too, which is one place that I think Python, I'm excited about after talking to people here, can really help us. Maybe not in a casual annotated way, but in a more directed, like this, annotated way. So in short, and I'm not going to bore you guys with the actual forecast here. You guys can read if you're all that interested in a forecast from 3 months ago. But the idea being that the model data that we're looking at here, the GEFS on the left, the euro on the right, there's a difference between the two. I don't like how either of them is playing out, in particular the euro here, because as my Cardassian friend says here, is anybody a DS9 fan, Star Trek? Okay, we got a couple of you guys in here. All right. Garrick is my favorite character in all of television. Basically, the point being that a lot of the model data that we were looking at looked really good day 1 through 5. We got into 6 to 10, there was a lot of variability there, and then back into 11 to 15, everything came back in and looked great again. And for me, as a seasonal forecaster, I look at that, even as just a general meteorologist, I'm going, yeah, no, I'm not going to trust data that coincidentally goes from being very certain about a thing to very uncertain about a thing. But no. Once we get through that uncertainty, we're definitely certain about things again. And as Garrick says here, coincidence happens every day. I see them. I don't trust them. Watch DS9. It's a good show. Graphics, not basic graphics. I learned that basic. Well, I won't get into that. I can't probably use PG terminology for that. Is this information, Susan, is this information overload to my public, probably? Yes, it is. It absolutely is. I will say this, though. I try to make things as simple as possible, and they say put more. They're like, well, why don't you put that on the same thing? And I go, okay. And so in the upper left here, we've got what's called a spray chart. Anybody watch baseball in here on a regular basis? Got any, like, baseball fans? Okay, so in baseball, they have something called a spray chart. I'm a huge baseball nerd, where they track where a player tends to hit a ball. And they'll show this graphic on TV, and it'll have all of these lines on it, kind of like a spaghetti plot, for where a batter is most likely to hit the ball. And I took this idea, and I said, okay, well, I'm going to apply it to individual ensemble members. And I'll talk more about this in a second. And so we've got the spray chart up there. We've got variability. How much variability is there in the data itself? So when an ensemble model comes out, is it, I went through and kind of tracked the average variability 1-to-1 as you get out in time, one ensemble member to the next member across all 50 members of the Euro and 31 of the GEFS. Was it 51 of the Euro? 31, anyway. We've got down here in the middle, looking at kind of some seasonal data, I took out all the stuff that is meaningless in there and only left the yellows and reds because I was told that that's a good idea. And then we've got some of the teleconnection data. And the big long chart here on the right is probably a bit too much information overload as well. However, it's really easy for my public to look at that and go, okay, we're going to be warm, then we're going to be cold in some places, or we're going to be cold and then we're going to be warm. And because they desire all the numbers, we kind of have to leave it in there. So let's talk more about the spray chart, which has that Riz. Riz is also a good thing. It's charisma, I've been told. That's the full word, but they shortened it because charisma takes too long to say and I guess isn't cool. So the idea being here is that each one of your ensemble, so let me back up. If you don't have a meteorologist on staff, generally in the energy sector, you're looking at the ensemble mean. That's it. You're trying to figure out what the temperature is going to be anywhere, you're looking at the Euro ensemble mean. If you have a meteorologist on staff, they're also looking at the Euro ensemble mean, just giving you a little bit of flavor. When I started, I said this is not enough information for you people because there's often times when the ensemble mean isn't telling the whole story. The whole story being that there is some risk within this ensemble, within all the ensemble members, for where things could be warmer or where they could be cooler. And this example isn't a great one, but this one is a fantastic one. This is a real forecast that I had to give to people, and I had to be accurate out 16 days with it. Good luck, right? So this is what it looks like on the spray chart. So I would argue that this tells its own story, which is, hey, it's CDDs, or in this case, HDDs, are going to go way up, and then they're going to go way back down, and then who knows? Yeah, exactly, yeah. But I think you can tear out a little bit of information with this if you add in some extra data. In this particular case, I think that you look at this and you find where are most of your ensemble members grouped? Where are they clustered? Where are they all hanging out? Well, relative to the mean, they're all hanging out a lot lower. However, that black dashed line in there is your operational guidance. And the op is just one deterministic model, but sometimes it can give you a little bit of a clue as to what the ensemble may be thinking. And the ensemble mean, which again is just the average of all of these things, is leaning a little bit closer to the operational guidance. Well, let me ask you guys, how many of you guys looking at this and just listening to me talk, or zoning out, one or the other, would go, I'm going to lean with the operational mean because it lines up closer to the, I'm going to take the ensemble mean because it lines up closer to the operational guidance. How many of you guys would just say, yeah, sure, let's do that? Okay, how many of you guys would go with the most likely, I guess most likely is probably I'm skewing your guys's. I'm doing exactly what I was telling Susan yesterday is a terrible thing to do, which is lead your audience. How many of you guys would go with the spray chart, which is the most of the members and where they are? Right, yeah, probably would. And so I didn't think that this was rocket science, but you would have thought that when I told the people that I work with about this thing, that it was the best thing since sliced bread. Moving on, so here's another bit of graphical data that is a quandary. I'm sure you guys are all, in fact, I'm just going to let you guys look at this for a second. Does anybody want to take a stab at what this is showing? Yeah.
Deviations from the average, or deviations from climatological?
From the 10-year. Okay, yeah. So, where are we deviating from the 10-year norm? If you're higher than that line, you're warmer. If you're lower than the line, you're cooler. Okay. What about the tic-tac-toe board? Anybody want to take a stab at that one? Yeah, take another stab.
Is that just for visualization, just to show where the 10s are? Because I see one at 60 and one at 70 on both.
So thinking back to HDDs and CDDs, this is a good way of picking out where is your demand and what is the demand. And the tic-tac-toe board would be if you're plopped in the middle, the idea being that you're not supposed to have any demand and you don't. Your forecast is lining up with climatologically where you should be. But you get into, say, the upper middle, and that's places that have demand that shouldn't for heating demand, and then down below, or for cooling demand, and then down below for heating demand. The idea being that my public can look at this very quickly and figure out where is the demand, what is the demand, and how do I need to position myself relative to that. For instance, the reason this matters is if in the Northeast, the heating demand in the Northeast is heavily gas, the cooling demand in the West is heavily renewable. So if you are a commodity trader and you're trading renewable energy or you're trading gas energy, this becomes very important for how you balance and manage your day and your portfolio. So this is another situation where if you guys had no information, you guys were able to figure it out. But if I just told you this graph is where the temperature is different than expected, right? Like that's not a very good way to explain it. Instead, you need to walk people through what they're looking at, and that's what I try to do here. And that's what I tried to do with my public originally, and now they can just look at this, grip and rip, and run. Other examples that we tend to use in terms of data visualization is not only what is the forecast, but how has it changed from 6 hours, 12 hours, 18 hours, 24 hours ago. So that's another part of our job. And this is where, honestly, we could use some more help as well from all of you wonderful data visualization people out there. Because a lot of this stuff they need right away. This is stuff that they need right away. So I'll just be sitting working. I've already kicked out all the forecasts for the day, and they'll turn around and they'll be like, hey man, I noticed temperatures in California are, a couple degrees warmer than they were yesterday. What was the forecast yesterday for California today? And I need to have that information right then, because the only reason they're asking is because they're trying to manage their portfolio. So being able to write a script, have something on demand that you can put in, hit a button, and get that information immediately instead of having to dig it up becomes very important. Slay is the communications CEO, fam. Do it. Again, these were all okayed. These all made sense to the person that sat behind me. I just went with it. So we do daily updates on a 60-day forecast as well. And sometimes we do twice-a-day updates on a 60-day forecast. And you might be asking, how much can a 60-day forecast change in one day? It's a 60-day forecast. Not that much, but not that much tends to mean a lot when you're working with our public. And that's something that I had to get used to. So again, being able to visualize things like this with numbers, with graphs, that they can easily grab and run with and understand what's happening becomes very important. And again, this is where Python comes into play. We partnered with a vendor out of Germany. They offer some downscaled data, which we're able to zoom way into our ship channels and get very finely tuned data, which is accurate as you can get in terms of what they do. And you can actually see, I'm going to step away from the microphone here, but it's probably tough to see looking up here, but if you guys look on your screens, you can see that the difference in temperature between where our terminal is and just down the street is about 5-6 degrees. That becomes very important because the efficiency at which we can turn our natural gas into liquefied natural gas is very temperature and humidity dependent. And then as we move that from where we liquefy it onto the boat, that is also very temperature and humidity dependent. And the efficiency at which we can do that becomes very important when these vessels that are toting LNG are worth hundreds of millions of dollars. And so being able to look at temperature data this finely tuned becomes very important for our terminals. And then being able to get a good fog forecast from the terminal out the channel and into the Gulf of Mexico also becomes very important, because the faster we can move this stuff in and out, the faster we can load up the next ship and sell that. We use a lot of Excel, and on the first day I asked the question of, how do I remove all of my colleagues from Excel and get them onto Python? Because we use a lot of Excel, and we've tried our best to come up with visualizations and the hard-coded numbers in Excel as best we can that is not overloading our public with too much information, but they do ask for it. The guy that you're looking at the bottom right there is basically HDD, CDDs, your renewables, and how much that is relative to each other. So you can think of this as the heating demand is in blue, the renewables, solar and wind, are in yellow and red, and the difference between those two stacks are where we're going to have to come up with demand that is going to be non-renewable based, and they then make their decisions off of that, and they can just kind of grab and go. I will say, after listening to Susan talking to her a couple of times, I am looking at this going, these should probably be stacked columns, because that would probably make more sense for them. So this is why you come to these things. You learn stuff. Viz, this is not mid. This is actually turns out to be pretty mid stuff, in all honesty. Mid is not good, by the way. Mid is very bad, which was confusing to me when I learned this, because mid to me seems like middle. It'd be like average. But no, mid is very bad. You do not want to be mid. So professors, if you're ever in class and you got a kid that's like, dude, this test is mid, you can be like, hey, deal with it. I don't know what you would say to him. But yeah, so we try and graphically represent changes, deltas, temperatures, everything that we can. Our guy on the right here is basically the forecast that we give to our terminals every day. And this is basically just a stoplight. Because we have to make it basic for them for many reasons. Part of the reasons is this is the stuff that goes to some of those ship captains, but also because the guys that are running the plant have nowhere short of about 25 TV screens and monitors in front of them with varying different things that they're watching, temperatures, pressures, etc. They don't have time when looking at a forecast to try and figure out, do I need to care about this forecast or do I not need to care about this forecast? So we give it to them in a stoplight so that they can go, okay, it's 3 o'clock on a Wednesday, it's red, that means I need to pay attention to the weather and change my dials accordingly. A quick note about where data visualizations can be kind of incomplete is the spaghetti plots. Matt Lanza, I don't know if some of you guys probably know Matt Lanza. I work for him, he's a great guy. He did a great job with this forecast for LoRa. And where visualizations can come up short, that's where us meteorologists have to step in. Because, again, at other places, they'll look at something like this. And if I'm at another energy shop and there's no meteorologist in place, I would look at this in Houston and go, oh, well, it's either going to go to our south or it's going to go to our east. We're fine. No problems here. And it turned out that then all these spaghetti shifted. And then they said, okay, well, I'm in Houston. I'm going to be on the right side of the hurricane. I'm going to be in a lot of trouble if I'm in Houston. Well, it turned out that this was not an accurate look from the Euro. Surprise, surprise, it's had some tropical problems the last couple of years. But our assets in Sabine Pass, which right there, or on this map, right there, needed to pay close attention, even though it had shifted well off to the west. Matt made the call 36 hours out, and that's the other thing that we have to do is oftentimes make calls far sooner than most other people. 36 hours out, he says, we got to shut down the plant, and shutting down an LNG facility is no small order. It's kind of like shutting down a nuclear power plant. Like, you can't just flick a switch and be like, all right, well, we're not doing power anymore. You got to bring it all the way down, and then to turn it back on, you don't just flip a switch and turn it back on. So he did a great job there. You get 5 internet points if you know what this GIF is from. Anybody want to take a stab at it? No 5 internet points for anybody. Okay. Watch News Radio. It's a great sitcom from the 90s. So we use visualizations a lot of times to communicate risk and variability within a forecast, basically. And our visualizations, they need to be kind of straightforward and pretty grip and rip so that our decision makers don't have to talk to us. We like talking to them, don't get me wrong. I like people. But we need them to just grab it and go. And they need not only the visualizations, but they also need the numbers because they have their own stuff that they look at. And just like everywhere else, your visualizations are kind of only as good as the communication that supports it. And this presentation won't ghost you. Thank you.